Sure. Magnetic properties of material beta. Okay. Very important topic and theory based beta. Generally, students get a little bit of your awkward to do the theory part, but it is very important for the competitive examinations like NEET and as well as of the other competitive examinations for the engineering also. But any of we're talking about the NEET examination. So for this one, we'll be talking about the properties of metal in the form of dia, para, and as well as of your ferromagnetic. And theoretical questions have been based upon this, and we'll try to do all of them. And there are some graphical questions also. We need to do even that graphical questions. Okay.
Yes.
Sure. You know that every electrons revolve around the nucleus beta.
Yes.
I hope.
Yes, sir.
Isn't it? I have just shown this right now somewhere. Just let me show you this slide. I don't know. Yeah. Isn't it? This is your basic atom relation. In the central part, we have what beta for us? Nucleus. Isn't it?
Yes.
And the remaining, the electrons are being revolving around this one. So this is a complex motion beta. We are not talking about that one. But if you see this relation, the way we draw the diagram, this is the first orbital, second orbital, third orbital. And all the electrons are being revolving around that in the circular orbits part. We generally take the circular orbit, but see the motion is very complicated motion. It all depends how you see the motion part of relation.
Yes.
Okay. So this is the relations. If I'm seeing this one even in my space, see right now somewhere I can show you.
Yes. Yes, sir. Now it's coming. Sir. Yes.
It's coming now. So this is the basic conditions what we see. The central part again we have lot number of particles.
Yes.
So what we're talking about the diamagnetic, paramagnetic materials, we are just talking about these atoms which have been aligned in a sequence way and in which there is a motion of the objects. Okay. So stop that one. Let's try to go for topic. Teacher. Yeah. So in the diamagnetic material substances, what is happening beta? Diamagnetic substances are those which will get feebly magnetized opposite to the field when they are being placed in an external magnetic field. Okay, no? Feebly magnetized means beta, feebly magnetized part of relation. What do you mean by feebly magnetized? Easily, isn't it? So the diamagnetic substances are those which will get feasibly, they are getting feasibly magnetized part of relation. They are getting feasibly magnetized. Feebly magnetized. Opposite to what beta? Field. Opposite to your field when placed in an external field. Now, in case of diamagnetism, if I draw the graph between I and H, what is I beta?
Sir, I is a magnetization.
Now, very good. I is your magnetization and H is your magnetic field intensity. H is your magnetic field intensity. So if I'm drawing the graph between magnetization intensity, it is directly proportional beta. I'll tell you why I will get the negative sign here right now. See, the magnetic susceptibility is given with the formula beta. Psi is equals to how much for me? I by your H.
Yes.
And is small and negative. That is approximately 10 to the power of -5. And it is independent of temperature. This is also theoretical question. The diamagnetic substances or susceptibility is independent of temperature. The relative permeability formula is beta.
Sir, can you little bit zoom in, sir, because there is
okay,
yes. Yes.
Sure. Okay. Relative permeability is nothing but what beta? Ratio of your mu by mu naught. Mu is nothing but what? Permeability of medium. Mu naught is nothing but permeability of your vacuum or free space. And it is slightly lesser than unity beta because mu is lesser than of your mu naught. So mu value already we know. Mu value is equals to much better. We know the value of your mu. Mu value is equals to your mu naught into 1 plus of your susceptibility. Size is small and it is always for me what? Negative. Clear?
Yes.
Sure. When a bar of diamagnetic metal is being placed in any external magnetic field, see this is an external magnetic field, and we are keeping a bar of diamagnetic material is being placed in external magnetic field. The field lines gets repelled. The field lines get repelled, and the field inside the material is getting reduced. So B is lesser than of your B. B is lesser than of your B naught. Actually, when you keep any magnetic material, the magnetic field of that one should be increasing, na?
Yes, sir. It'll attract.
Because you are keeping an external magnetic field.
Yes,
But
sir.
here it is reducing. That is a basic thing you need to remember in the diamagnetic substances. Whenever it is being placed in external magnetic field, the field lines get repelled and the field inside the material is being reduced. This is the diagram you need to remember. This is the bar magnet. This is the bar of diamagnetic material. When it is being placed, the magnetic field of this diamagnetic field is lesser than the external magnetic field. Clear?
Sir, the reason is because it is lesser than the external magnet.
It is lesser than, it is becoming negative now, because this is having a property of repelling. It is not allowing this magnetic lines of the force to pass through them, isn't it?
Yes.
Isn't it? So whenever a bar of a diamagnetic material is being placed in an external field, the field lines get repelled. And when the field lines are being getting repelled in this one, so then what is happening to the magnetic field of that one? For repelling, it will be using its own energy. So what is happening to its energy? Its energy will be decreasing. So its energy is decreasing, its magnetic field is also decreasing. Is it clear?
Yes, sir.
Chalo. In the same way, if a superconductor is being placed in a magnetic field, then inside the superconductor it is zero, which is called as of your Meissner effect, which is known as of what?
Yes,
Meissner effect part of relation. Okay, so
yes.
the superconductors or the conductors will exhibit a perfect diamagnetism here right now, isn't it? They exhibits the perfect diamagnetism. So if a superconductor is being placed in a magnetic field, the field inside the superconductor is zero, which is known as Meissner effect. The superconductors exhibits the perfect diamagnetism. This also you need to remember better. Which materials will be exhibiting the what do you call that one? Perfect diamagnetism means superconductors will be exhibiting. Superconductors will be exhibiting the perfect diamagnetism. Superconductors exhibits your perfect diamagnetism. So what is the formula for the magnetism beta? B is equal to mu naught into H plus I. Yesterday I told you,
Yes, sir.
isn't it? So if the magnetic field B value is becoming zero, that means I value will become for me how much beta? Minus of your H,
Minus.
because mu naught is becoming for me zero, so I is
Yes.
equals to minus H. So susceptibility will become how much for me beta? Susceptibility is equals to how much for me? I by H. I value is how much? Minus H. Minus of H gets cancelled, so that will be equal to how much for me? Minus 1. So
Yes, sir.
relative permeability is how much for this one? 0. Relative permeability is equals to 0. Is it clear? So whenever a superconductor is being kept in external magnetic field, the magnetic field will become for me 0. The magnetic field will become for me 0. Is it clear?
Yes.
Sure. Next one. The diamagnetic substances are weakly repelled by the field beta. The diamagnetic substances are weakly repelled by the magnetic field or field, whatever we are taking. Hence, in a non-uniform field, this have a tendency to move strong to the weak field. Because
Yes,
whenever you are keeping in this one, they're getting repelled, isn't it? So that means the diamagnetic substances are weakly repelled by a field. Hence, in a non-uniform field, this have a tendency to move strong to a weak field. That means the diamagnetic substance becomes perpendicular to the field if it is suspended between the bar magnet. This is very, very important. The magnetic substances, whatever the magnetic substances we are taking, they become perpendicular to the field if it is suspended freely between a magnet. Like say this is a north and south pole, and this is a bar magnet which has been hanging, isn't it? So whenever a bar magnet is hanging between the two short bar magnet, and this is what type of a metal beta? Diamagnetic material. It is made up of what? Diamagnetic part. So diamagnetic will always become perpendicular to the field.
Okay, sir.
Okay.
Yes.
In the same way, this one. A diamagnetic liquid in a U-tube. In this U-tube, we are having a diamagnetic liquid which get depresses in the limb, which is being present between the poles. If this one side of the jar, if it is been kept in the strong magnetic field, this side of liquid will show the depression like this. So,
Sir,
and the other side of this one, there
weakly repulsion, right, sir? So then why is it
there is
moving,
repelling.
sir?
This is a magnetic metal, but this is repelling. So this magnetic field will repel this one. Because of that repulsion, what is happening? The liquid will try to come down. So there will be a sort of repulsion, Gada. So because of that repulsion, there will be depression will be seen here right now. So because of this depression, the other side of the liquid or the other side of the diamagnetic metal will be increased. Okay?
Yes.
Isn't it? So whenever a diamagnetic liquid in a U-tube is depresses in the limb, which is being present between this one. So they get depressed. They get depressed because it should be get repelled, Gada. So when it is
Yes,
getting
sir.
repelled means what is happening? See, this is the
It's
liquid.
moving down.
When it is getting repelled means what happens? This side and this side is getting right now fully pulled. So what happens?
Yes, sir.
Slowly this will become this much shape. Will take the shape weight of pollution.
Yes.
Clear?
That's why the water also will move down, right, sir?
Yeah, that's also condition. Now see, this is something very important thing which I need to tell you detailedly. Origin of the diamagnetism, whatever you get, the origin of your diamagnetism is, we know that electrons in an atom is around moving or orbiting around the nucleus. There is a reason that I have shown you the basic diagram initially. The origin of a diamagnetism is because of what, beta? We know that electrons in an atom orbiting around the nucleus possess what type of your momentum, beta? Orbital angular momentum. They possess
Yes.
your orbital angular. The orbiting electrons are equivalent to what, beta? Current loop. The orbiting electrons are equivalent to what, beta?
Current
Current loop,
loop.
and they possess orbital magnetic moment. They possess what? Orbital magnetic moment part of relation. Clear?
Yes, sir.
Isn't it? And they are the magnetic moment of an atom is mainly due to what, beta? Orbital motion of your electron. That means the orbiting electrons are equivalent to the current loop and they possess the orbital magnetic moment. So in the diamagnetic substance, the resulting magnetic moment is zero. So when a magnetic field is applied, the substance develop a net magnetic moment in a direction opposite to the applied field, and hence there will be a repulsion. Some of the best diamagnetic materials are bismuth, copper, Pb is nothing but what, beta? Lead, I can say.
Lead.
Pb is
Plum. Yes.
lead. Si is nothing but what?
Silicon.
Silicon, nitrogen, even copper. Gold is also one of the best example. You can even write here right now for me gold. Gold is also a diamagnetic material. Even quartz is also a diamagnetic material. Mercury is also a diamagnetic material. Better water is also a diamagnetic material. Even alcohol is a diamagnetic material. Air is a diamagnetic material. And hydrogen is also a diamagnetic material. Hydrogen is also a diamagnetic material. And bismuth I already have given. Copper is
Yes.
also been. Apart from this one, these are all also called as the diamagnetic material particle relation. Is it clear?
Yes.
Isn't it? So what is the basic reason for the diamagnetism, beta? An electron which is revolving around the nucleus of an atom constitute a current loop, and this current loop will behave as of your magnetic dipole. Will behave as a what? Magnetic dipole. And the magnetic moment of an atom is mainly due to what, beta? Orbital motion of your electron. Orbital motion of your electron. What is the
Yes.
net magnetic moment of an atom, beta, in this one? Zero. Magnetic
Yes.
moment will be equal to
Zero, sir.
zero. Net will be equal to zero in the diamagnetic material. Why? Because in the orbital population, we know that if I'm filling the orbits, there are fully like this, beta.
Yes, sir.
So if I write an atom, so in an atom of some materials, electrons are in pairs, and the magnetic moments are right now paired electrons will get cancel each other.
Yes, sir.
And the net magnetic moment will be taken. So this is nothing but because of what, for the orbital condition, and this is nothing but what for your atom. For an atom, when I'm writing the electrons are equal and opposite, so they will get cancel each other. Is it clear for everyone? So what is
Yes.
the net magnetic moment for this one? The net magnetic moment will become for me zero. The net magnetic moment will be zero. That means there is no magnetic dipole, then there is no atomic dipole also in this one. So I can say here right now, there is no magnetic dipole. There is no magnetic dipole, and also there is no atomic dipole. Dipole means what, beta? Both north pole and
Two poles.
south.
North and
North
south.
pole
Yes.
and as well as of your south pole. So that is the reason whenever we are taking a diamagnetic material, so in this one, this will be the shape. Okay, this is your diamagnetic substance. So magnetic moment will be equal to how much, beta? Net magnetic moment of this one is becoming for me zero. Is it clear?
Yes.
Okay, so whenever an external magnetic field is applied across any material, beta, there will be two effects. One is atomic dipole, dipoles in the material will align an external magnetic field, beta, and there is an induced magnetic dipole also. Whenever you are applying an external magnetic field particulation, then whenever an external magnetic field is applied across any magnetic material or any material, there will be two effects. One thing is all the atoms will get arranged in one manner. I told you right now, say for example, this is a classroom and every student is been randomly moving here and there in the classroom. The moment the teacher comes into the classroom, what
Everyone
happened?
will align.
All of this one will become in one order.
Yes.
They will align in one single order, right? And everyone will try to become aligned. So this
Yes.
alignment is because of what, beta? External magnetic field. Isn't it? So
Yes,
that's
sir.
what I tell you, that if there is an atomic, whenever an external magnetic field has been applied across any material, the atomic dipoles in the material will align themselves. That means angle between the north and south pole will be equal to how much, beta? This poles will be equal to how much? This is south pole, north pole, south pole, north pole, south pole, north
180
pole, south
degrees.
pole. So theta will be equal to 0
Zero,
degrees
zero.
along
Sorry, yes.
direction field. Gada. So
Yes,
this
sir.
is also the field B bar, and the magnetic dipoles are also in the same direction, isn't it? That means I can say that H is in this direction and magnetic moment is also in this direction. Angle between them is how much for me? 0 degrees. What is H beta? Magnetic field intensity.
Yes, sir.
And capital means magnetic moment. So angle between them, or if they are in the same direction, theta is how much for me? 90 degrees. So what will be the
Yes.
potential energy for this one? U is equals to minus of your MP into your cos of your theta. Theta value is 0 degrees. Cos 0 will become how much for me? Minus of your M into your B. Clear?
Yes.
Then which is minus means this will become for me what? Minimum. So this will become for me U minimum. That means when it is U minimum is it stable equilibrium or unstable equilibrium? It will be your stable equilibrium and stable equilibrium. It will be your stable unstable. In
Sir,
Japan already.
US minimum means it will be stable on your also.
Yeah, this will be your stable equilibrium. Okay, na? Is it
Yes,
clear?
sir.
Is it clear?
Yes,
So
sir.
whenever an external magnetic field is being applied right now, induced magnetism will be very, very small. So in this one right now, what is happening right now? All of them, the magnetic energy will become for me minimum, and that will be equal to your minus. So in diamagnetic substance, what is happening is there are no atomic dipoles property, there will be no alignment. Ante kada? See, in the diamagnetic material, you know that in diamagnetic material, in diamagnetic material, there is no atomic dipoles.
Yes, sir.
That
No
means there is no
atomic
north and
dipole.
south.
Yes,
That means there is no alignment. That
yes,
means
sir.
there is no alignment. When there is no alignment means what? Magnetic moment will be 0. Ante kada, there will be no
Yes, sir.
magnetic alignment at
So
all.
it is very
Isn't it? So
stable.
hence the diamagnetic substance are weakly repelled by your applied magnetic field. Ante kada.
Yes,
So I
yes,
can say that diamagnetic substance are weakly repelled.
sir. So here
Weakly.
stability would be less, right, sir, because they won't align because of the
Yeah, the
absence.
stability will be less participation,
Yes,
isn't it? Because when magnetic dipole itself is not like plastic. If you keep a plastic in a
yes,
magnetic field, will it act as if a bar magnet? Will it
no,
show any
sir.
property of magnetic?
No,
No,
sir.
no, because there is no magnetic dipoles present in that one. If already
Yes, sir.
some magnetic dipoles have been present, and if you're keeping in magnetic field, then only it will get magnetized. So in
Yes, sir.
magnetic field, there is no atomic modulus population. The southern. So there are no atomic dipoles. So there will be no alignment,
Yes, sir.
isn't it? When there is no alignment means they are weakly repelled by the applied magnetic field. They are weakly applied by your magnetic field. Is that clear?
Yes, sir.
Isn't it? So that was about the basic condition you need to remember. And what is the magnetization beta right now here? I value is positive or negative? Just now I told you.
Sir, it's negative,
Susceptibility
sir.
is negative, I told you. Susceptibility is negative. So I value is also negative. Isn't it? I
Yes,
value is, and magnetic intensity will be what beta? Positive. Is it clear?
yes, sir.
Got an idea?
Yes,
అర్థమైంది ఇది చూడు ఇక్కడ ఆల్రెడీ నేను రాపించాను చూడు ఇక్కడ susceptibility లా where they have written right now that point here. Susceptibility is how much for me? -1. And what is the susceptibility? Susceptibility is equals to how much for me? Susceptibility is equals to your I by H kada, isn't it? I value how much we got right now? -H. So this will
yes,
be
sir.
equal to -H divided by H. This H will get cancelled. So susceptibility value is how much for me? -1. Isn't it?
Yes,
H
sir.
value will be equal to how much? Positive. So if net magnetic field is absent, then intensity of magnetization will become for me negative of your magnetic field. Isn't it?
Yes,
And the graph
yes,
of your intensity versus your H will be a straight line passing from the origin.
right.
Like if I ask you to draw the graph of susceptibility, see this one. If this is the graph of your susceptibility versus your I, say for example, of your side with respect to temperature, if I'm right, with respect to temperature. The diamagnetic metal is independent of temperature. I told you better just now.
Yes.
Isn't that means susceptibility does not change with your temperature?
Yes, sir. It will remain
Isn't it?
same, sir.
It is independent of temperature. It is independent of temperature. He has just given a word. See, I'm drawing a graph for that one. Tomorrow he may ask you the graph for that one. When it is independent means susceptibility does not changes. So
Yes, sir. Straight line.
susceptibility, yeah, so does not change. It will does not change with the temperature. With
Yes, sir.
your temperature. So that
Parallel
means what
to
type of graph
x-axis.
I'll be getting? Very good. So that will be your axis like this.
Yes, sir. Got it.
Positive or negative? We are doing one mistake again. What is that? Can you tell me? Susceptibility was negative, Gada. So when susceptibility is negative means this graph I should take right now. If this is positive, this
Okay,
should
yes,
be the
sir.
susceptibility, na?
Yes, sir.
-1. That means the graph should be in the downward direction right now, but not
Sir,
above.
but okay, yeah,
Like that.
susceptibility is -1, right? So here we are
Yeah,
getting
susceptibility is -1. That is the reason we'll get
yes.
the graph down this one, but not above that.
Sir, but I didn't.
Clear?
One thing I didn't understand is anti-magnetization. Why are we getting negatives?
Why? Which one?
Magnetization of diamagnetic substances.
This one I told you, no, actually, the
Once,
intensity of magnetization, what we are taking right now, we are getting negative from this one. You see, if a
yes,
superconductor is being placed in a magnetic field, the field inside the superconductor is zero, which effect is known as what? Mesner effect.
listener effect,
That
yes,
means the superconductor is exhibiting perfect diamagnetism. That means external magnetic field is having no role on that one.
okay, okay, yes, okay, that's why no
If B
magnetization,
value is
yes,
zero, B by mu naught value is zero. So H is equal to minus I, gada.
minus, yes,
Isn't it? That
yes,
is the
sir,
reason
yes, sir.
intensity of magnetization is negative.
Okay, sir.
Got an idea?
Yes, sir.
So that was the story about your diamagnetism. I hope you got a clarity about your diamagnetism. So
Yes, sir.
diamagnetic substances are those which are feebly magnetized and opposite to the field. And whenever you are drawing the graph between I and H, it will be a straight line passing from the origin. And if I'm drawing a graph between the susceptibility and temperature, that will be the straight line in the negative x-axis or in the below the axis part of a relation. And whenever a magnetic material is being placed in external magnetic field, they get repelled and the field inside the material is generally getting reduced. And the relative permeability for this one is 0. Susceptibility is -1. And it is independent of what, beta? Temperature. It
Temperature.
is independent of your temperature part of relation. Is it clear? So need to
Yes,
read the theory very, very carefully. And whenever a diamagnetic liquid is being taken in YouTube, the depression in the limb is being seen wherever the magnetic field is being present. And net magnetic moment is rate of for 0 because there are no atomic dipoles or magnetic moment will become for me 0. The best example for the diamagnetic materials are bismuth, copper, lead, gold, silicon, nitrogen, quartz at NTP, H2O, and NaCl. At your general condition, hydrogen is also one of the best example. Mercury, water, alcohol, air. All the diamagnetic substances have been present in all the substances, but the effect is so weak that the most cases of it gets shifted to the other effects, the paramagnetic and ferromagnetic effect part. And almost all the percent, all the matter will possess of your diamagnetic substances part of relation, because we also have an atoms in our body, better.
yes, sir.
But when a bar magnet is going decided, we don't feel that much of magnetic effect inside us, isn't it?
Yes, yes, sir.
That is the reason. Okay. Sure. Next one, so this is also the theory I have given something right now. So there is no magnetic dipole, there is no atomic dipole. So everything is being kept like this. So net magnetic moment for this one is 0. So whenever a magnetic field is been applied, it should become a straight line, and intensity of what do you call that, when in same direction, magnetic moment in same direction. So theta value is 0. And my potential energy formula is what for me, beta? Minus of MB into cos plus U minimum is equals to minus of your MB. In diamagnetic material, there is no atomic dipole, so there is no element. That is the reason diamagnetic substances are weakly repelled by the magnetic fields. Susceptibility is negative, intensity of magnetization is also negative, and intensity of magnetic field will be equal to your positive, and it is
Sir,
independent
so
of what?
now I is equals to minus h, right, sir?
Yeah.
So that time, sir.
No, we got this one from the basic
Listeners
formula.
effect, yes.
Mu r value is equals to, isn't
Okay,
it?
yes.
Mu r is equals to mu naught into 1 plus of your susceptibility research.
Yes.
So mu r value anta 0 kada. So everything is 0. So 1 plus I is equals to 0 kabatti 1 will be equal to how much for me? -1 kada.
Yes.
Okay. So that was about your diamagnetic material.
Yes.
Next one, paramagnetic substance. See, paramagnetic substances are nothing but these substances are weakly magnetized. So these substances are weakly magnetized in the direction of the field when placed in an external magnetic field. Whereas the diamagnetic field, beta, feebly magnetized,
Yes, sir.
isn't it? So these substances right now, whatever I'm taking right now, these substances are weakly magnetized in the direction of the field when placed in an external magnetic field. So in the what do you call that one, paramagnetic, if I'm drawing the graph between I and H, again it will be a straight line. Here I is directly proportional to your H beta.
Yes, sir. And this time positive, right, sir?
Positive. The magnetic susceptibility is small and positive. That is 10 to the power of minus 3 to 10 to the power of minus 1. And it is independent of the field, but it is inversely proportional to absolute temperature. Very, very important formula. Susceptibility is inversely proportional to your absolute temperature, which is called as Curie law. Removing the proportionality constant, we are getting some constant known as of your C. Okay, now, or K also you can keep, no problem. So susceptibility is inversely proportional to temperature, which is known as Curie law, and C is known as of your Curie constant. So what is the condition? This paramagnetic substance is independent of the field, but it is inversely proportional to your absolute temperature. That
Yes.
means if the temperature is increased, susceptibility will decrease. If susceptibility is decreasing, temperature will increase. Clear?
Yes, sir. Clear, sir.
This is very important, but a numericals we will be getting a lot number of a question. The relative permeability is slightly greater than 1 beta in this one. So mu is greater than mu naught. Whereas in the previous case, if I take right now, mu is lesser than of your mu naught. This point also you need to remember it. Mu is lesser than mu naught. That means mu of the medium is lesser than of your permeability of your what beta? Air or vacuum. And the
Yes.
absolute
Yes, sir.
permeability. Here in this one right now, what I am writing, the relative permeability mu r, the relative permeability mu r, this one is your r, is slightly greater than 1. That is the reason why I'm writing here mu is greater than of your mu naught.
You know,
The
means
magnetic field B is slightly greater than the magnetizing field beta here. So here B is greater than of your B naught. Whereas in the diamagnetism beta, in the diamagnetism,
B naught
B is
is greater.
lesser than of your B naught. B is
Yes.
lesser than of your B naught part affiliation.
Sir, so
Paramagnetic
here,
will be greater.
sir, so after the magnetic field lines didn't they repelled the magnet,
Yeah,
right,
they
sir?
repelled here, but right now here they will be inserting in
Attract.
this.
So, yes.
Okay. Na? So the paramagnetic substances have a tendency to pull the lines of the force when they have been placed in the magnetizing field part affiliation. That means
Yes.
this will be the condition. They have a condition to get
Okay,
pulled
sir.
themselves. So the magnetic lines of the field will be passing through that one. That is the reason B is greater than of your B naught. Okay. And this one is also
Yes.
very important beta. The substances are weakly attracted by the field. So in a non-uniform field, this have a tendency to move toward strong field. In what field? In a non-uniform field, they have a tendency to move towards the strong field. Whereas the paramagnetism in the non-uniform field, they have a tendency to move to your strong to weak field. They are having the tendency to move from your weak to your strong fields. Yeah, opposite.
Yes,
Exactly opposite particulation. Okay, that means a freely suspended paramagnetic rod will become parallel to the field, whereas the paramagnetic will be becoming perpendicular to the field, isn't it? Here it
Yes.
is becoming perpendicular. The diamagnetic substance will become perpendicular to the field, whereas a paramagnetic substance will become parallel to the field. They become parallel to the field. See here, north and south, they will become parallel to the field. That means a paramagnetic liquid, if I'm talking about your paramagnetic liquid in a U-tube, will ascend between the poles of your magnet. Ascends means what?
Go up,
Rises.
sir. It will go up, sir.
Go up. Whenever it is going, whenever a paramagnetic liquid is being kept in the strong paramagnetic field, it will be rising. That magnetic field will be rising. Is
So
it
due
clear?
to attraction, right, sir?
Yeah, due to your attraction.
Yes.
What an idea?
Yes.
So the origin of paramagnetism, see better. The individual atoms or ions or molecules of a paramagnetic material possess a permanent magnetic dipole moment better of their own. On account of this ceaseless random thermal motion of the atom, no magnetization is being seen in this. There is no net magnetization. There is no net magnetization seen. In the presence of an external field B naught, at a low temperature, the individual atomic dipole moment can be made to align and point in the direction of B naught. So field is increased, so temperature is being lowered. So the moment the temperature is lowered, magnetic field will be increasing. That means the magnetization will increase until it reaches a saturation point, so at which all the dipoles are perfectly aligned with the field. Beyond this, Curie law is not valid. That means up to certain point only we can magnetize them. Some of the paramagnetic substances are what beta? Aluminum, sodium, calcium, oxygen at NTP, and copper chloride at your NTP are the best examples for your paramagnetic substances. Here, just read the statement better. If you're having any doubt, you let me know. In the
Yes, sir.
diamagnetic, there is no dipole moment better. There is no atomic dipole moment. Whereas
Yes.
here there is a dipole moment, and because of the decrease in the temperature, the magnetizing field is been increasing in this.
Yes.
Okay, now.
Sir, so they're inversely proportional, sir.
Yeah, inverse, and it is inversely proportional to the temperature.
Yes.
Yeah.
1 minute, sir. 1 minute.
Hmm?
ఒక్క నిమిషం, sir. 1 minute, sir. I'm just reading that last point, sir.
Yes, Steve. Sorry.
Sir, I didn't understand no net magnetism. Okay, because yes, sir, got it, got it. Because dipole moment is there, net magnetism is zero, right, sir?
Exactly.
Yes, sir.
Clear? Huh?
Yes, sir. 1 minute.
Study it better. Very important, because now you need to do even theory questions based on this.
Yes. Sir, so magnetic field is directly proportional to magnetization, and temperature is inversely proportional, right, sir?
Yeah, inversely proportional. See here, what is a Curie law we have written there, beta? So Curie law says that susceptibility is inversely proportional to temperature. Susceptibility, yes. So where do you get the susceptibility, beta? We are getting the susceptibility from which formula? This formula. Susceptibility is equals to I by
I is
H.
equals to I. Yes, sir. Please, sorry.
Okay.
Yes, sir.
Any other point you have doubt, you let me know.
What, sir? Sir, now, sir, once can you show where you are getting susceptibility from, sir? I is equals to susceptibility. Sorry, H is equals to susceptibility into I, right?
Susceptibility is equals to I by H, no?
I by H, yes, sir.
Isn't it? Now, susceptibility was inversely proportional to temperature.
Yes, sir.
The susceptibility by your T, that is equals to intensity by your H. That means as the temperature is being decreasing, magnetization is increasing, but intensity of magnetic field is decreasing.
Yes, sir.
Isn't it?
Yes, sir. Got it.
Got it?
Yes, sir.
Diagrams also go through it.
Sir, so basically, what is Curie's law, sir?
Curie's law says that, beta, what exactly is Curie was a scientist when he was doing an experiment. He
Yes.
found that whenever a substance of weakly means what a paramagnetic substance are weakly attracted by the field.
Yes, sir. Yes,
so
sir.
in a non-uniform field, they have a tendency to move always from weak region to a strong region.
Okay, sir.
Isn't it? So when you are going from weak region to strong region, they should be having certain amount of energy, because you're going from lower energy to the stronger energy.
Yes, sir.
Isn't it? See, going from higher to lower, it is very important, very easy.
Yes, sir.
But getting from weak to strong, it will be, we need a certain amount of energy.
Yes.
That energy is in the form of temperature. That's what the Curie told that. So if the susceptibility is right now, what? The intensity of magnetization, because susceptibility is directly proportional to what, beta? I, and inversely proportional to intensity. If the temperature is decreased, the susceptibility is increasing. The susceptibility is increasing. The intensity of magnetization is also increased.
Yes, sir.
Isn't it? If the magnetization is increasing, that will be acting as a what? A magnetic property of magnetic material particulation.
Yes.
Okay.
Yes. Sir, so here the magnet will align parallel, right, sir?
Yeah, they will be aligning the parallel particulation.
And in diamagnetism, perpendicular, right, sir?
They in the align is in here it is 0 degrees, and there it will be your what? Perpendicular.
Yes,
in the paramagnetic it is, sorry, in the diamagnetic it is perpendicular, and paramagnetic it is parallel.
Yes, sir. In between two magnetic fields.
Yeah, right. And liquid, what happens in the paramagnetic? It rises. In diamagnetic, it will get depressed.
Yes, sir.
Okay, na? Next.
Yes.
Ferromagnetic substance. Ferromagnetic substances are those which will get strongly magnetized in the direction of the field when placed in an external field. Okay, na?
Yes, sir. Sir, ఇప్పుడు strongly కి feebly కి difference ఏంటి sir?
ఏంటన్నా?
అంటే ఇప్పుడు diamagnetism means feebly means easily it will get magnetized. So
Yeah.
ferro is the next level of being easily, sir.
Yeah.
Okay.
So ferromagnetic substance. Ferromagnetic substances are those which get strongly magnetized in the direction of the field when placed in an external magnetized. That means they will become very more powerful when you are keeping in the external field. So the intensity of magnetization is very large and positive and varies non-linearly with your H or with respect to your temperature. Got it?
Yes, sir. Sir,
Yes, but
now they're saying that means now our seniors are there, right, sir? Second year outgoing are there, right, sir?
mm,
They're gonna conduct exams in July or something, they were saying, sir.
జూలై కాదు, జూలై ఎక్కడైతుంది? అక్టోబర్ నవంబర్ అవుతుంది, అక్టోబర్ అవుతుంది, ఆగస్ట్ అన్నారు కదా, సెప్టెంబర్ అక్టోబర్ అవుతుంది వాళ్ళు.
నీట్ కాదు సార్, మన ఇంటర్మీడియట్ ఎగ్జామ్.
Yeah, intermediate they will be in the July somewhere.
And normal CBSE exam, sir, that also July, sir.
August.
Okay.
Maybe July
Okay.
ending or August first week or something.
Okay. Yes.
Let me do one question based on this one bit.
Sir, so this won't affect like next year, Marku, if the pandemic is normal, we'll have at the normal time of the day.
Yeah, pandemic is over, then it will be at normal positions. Okay.
Yes.
See this question better. For a magnetizing field, of intensity, for a magnetizing field of intensity 2 into 10 to the power of 3 ampere inverse, aluminum at your 280 Kelvin acquires intensity of magnetization, intensity of your magnetization of 4 into 10 to the power of -2 ampere per meter. Find the susceptibility of aluminum at your 280 Kelvin if the temperature of the aluminum, is raised to 320 Kelvin. Okay, so what will be the susceptibility? What will be the susceptibility and intensity of magnetization? And intensity of your magnetization. Okay.
Yes, sir. Sir, so here they have given HI, they have given, right, sir?
Yeah.
H
See
and
what
I
is given for a magnetizing field of intensity. That means what?
Sir, the H is equals to
Yeah, very good.
2
H is equals to 2 into 10 to the power of 3 ampere per meter.
Yes.
Sorry, ampere meter inverse.
Meter inverse, yes.
Okay.
Ampere per meter, yes.
At what temperature? Temperature is given for me at 280 Kelvin. Then what he has given? Intensity of magnetization. Intensity of magnetization means I.
Sir.
I value will be equal to 4 into 10 to the power of -2 ampere per meter.
Yes.
Okay. Find the susceptibility of aluminum at 280 Kelvin. Susceptibility, what is the formula beta with both of them? I is equals to susceptibility into your H.
Yes, sir. Susceptibility is equals to I by H.
Susceptibility will be equal to your I by H.
Yes.
Isn't it? So I value is how much we got right now. So susceptibility is equals to I value is 4 into 10 to the power of -2 divided by H. H value is 2 into 10 to the power of 3. So that will become for me how much? 2 ones are, this one is 2 twos are. So this 2 into 10 to the power of This will go up 10 to the
minus
power
5.
minus 5,
Yes.
isn't it? It has no units because the units will get cancelled because the
Cancel.
units have
Yes.
same property, both of them will get cancelled.
Yes.
What is the next part of a question is asking right now? You see, the next part of a question, if the temperature of the aluminum is raised to 320 Kelvin, that means initial temperature is T is equals to initially how much for me? 280 Kelvin. Now it has been raised to T dash is equals to 320 Kelvin. So for this one, the susceptibility is how much for me, beta? 2 into
2 into
10 to
10 to
the
the
power
power.
of minus 5. So for this one, what is the susceptibility and what is the intensity of your magnetization? So what is asking in the problem?
Yes.
So what will be the susceptibility and intensity of magnetization? Intensity of magnetization means what, beta? I dash. Now, what is the relation between the susceptibility and temperature? What is the relation between the
Susceptibility is
susceptibility and
inversely
temperature?
proportional.
Curie's law.
Yes, sir. Susceptibility is equals to C by
That is C by your absolute temperature. That means
divided.
susceptibility is inversely proportional to temperature only, na beta. So
Yes.
psi dash divided by psi will be equal to your T divided by T dash,
Yes.
isn't it? So I can calculate the susceptibility now. Susceptibility
Yes.
psi dash is equals to T into susceptibility divided by your T dash. So T is how much for me, beta? Capital T is 280 into susceptibility is 2 into 10 to the power of minus 5 divided by T dash. T dash value is how much for me? 320 Kelvin. This one will get cancelled. So this will be equal to how much, beta? Can you see?
Yes, sir. 1 minute, sir.
How many times? 7 by 8
1.75, sir. 1.75 into 10 to the power of
divided by 8. So this is 7 into 2 into 10 to the power of minus 5 divided by 8. And then,
yes, sir. 2 ones are 2 fours are.
yeah. So this will be 2 ones. This will be 2 fours.
Yes.
That means it will become for me 7 by 4. 7 by 4 into 10 to the power of minus 4. 7 by 4 means this will be equal to how much for me? 4 ones are 4 ones are 4. This will be 0.4, 5, 6, 7, 3. That means this will become for me 7 and this will become for me
0.7.
5.
Yes, sir.
It is 1.75 into 10 to the power of minus 5.
Yes.
What an idea.
Yes. Sir, just 1 minute, sir.
Yeah.
Yes, sir.
What is the next one? You tell me. Can you tell me the next one answer? What is the next question is next part? Susceptibility is over intensity of magnetization. That means I dash.
Yes, sir.
I
So
dash
we have
value is equal to how much? I dash is equals to susceptibility into
into
H. H will
H.
not change beta because it is your external magnetizing field. So it is not going to change. So I dash
So
is equals to
1.75 to
0.75 into 10 to the power of minus 5 into H. H value is how much?
2
2
into 10 to the
into
power
10
of.
to the power of 3.
Yes.
Got it?
Yes.
So see what will be the answer for this one bit. This is 1.75 was how much? 7 by 4 hai kada?
Yes, sir.
7 by 4 into 10 to the power of minus 5 into 2 into 10 to the power of 3. This one only, na?
Yes,
So
sir. So 10 to the power of minus 2
this
also.
is a 2 2s. So this will
Into
become for me
3.5, sir. 3.5 into 10 to the power of
3.5
minus
into
2.
10 to the power of minus 2 ampere per meter. Got it?
Yes, sir. Got it. Yes, sir. Clear, sir.
Clear?
Yes, sir.
Okay, one more question here. Think and tell me the answer carefully. Without thinking, don't give me the answer in hurry. Say, for example, which of the following best represents which of the following best represents variations of your I versus H by T for paramagnetic material. For a paramagnetic materials. Okay. So first graph is like this. Okay. This is
Yes.
first. This is second graph. The first graph is between your I versus your H by your I. It is a straight line passing from your origin like this. Okay. So the next one is okay. So this one is your I by H by your T. Okay. Graph is given like this. Okay. Next one is your third one. This one is your fourth one. This is your H by your T. This one is your I. The graph is something like this. It goes like straight line, then it will become like this. Okay. And the fourth one is something like this. This is your I versus your H by your T. Come on, tell me the relation. H by T represents me what? First, you tell me that. What is H by T? Which of the following best represents a variation of I versus H by T? Susceptibility is equals to what beta? I by H kada? Are you there?
Okay, sir. నేను అప్పటి నుంచి మ్యూట్ లో పెట్టుకుని was talking, sir. Sorry.
Susceptibility is what beta?
I by H, sir.
I by H or H by I?
Susceptibility is I by H, sir.
I by H na?
Yes, sir. I by H.
What is H here right now?
H is equals to I by
Intensity of
susceptibility.
intensity of
Magnet.
magnetization.
Yes,
I
sir.
is your magnetization kada.
Yes, sir. Intensity of magnetic field. H is intensity of magnetic field.
So H by T represents me what? H is what right now for me here?
Sir,
Intensity of
intensity of
magnetization, which is
magnetic
always
field.
remains for me constant.
Yes,
That
sir.
means 1 by H will be equal to how much beta? H by T will represents me what?
1 by
Susceptibility.
T. Yes, sir.
Reciprocal to your temperature.
Yes, sir.
That means if 1 by T increases,
1 by T increases, susceptibility decreases, sir.
isn't it? If 1 by T is been increasing, because see, I versus your H by T gada,
Yes.
straight line graph.
Yes, sir.
For the first one. So it is a straight line gada, like y is equals to k into your x.
Yes.
In the place of y, I am having I, and the k is your constant. In the place of your x, I am having h by t.
Yes.
Isn't it? K and h are constant gada. So in this one, if I'm writing here right now, if the temperature is increased, that means if 1 by T is increased,
yes.
So what is happening to the intensity of magnetization beta?
It will decrease, sir.
Isn't it? So that means if it is been increasing,
yes.
Isn't it? What is happening to H by T population?
If I is increasing, sir. If I is increasing,
H by
sir.
T is increasing. That means the temperature is right now. What is happening?
H by T is increasing means temperature is increasing, sir.
1 by T is right now increasing. Intensity of magnetization?
It will remain, magnetization will decrease. Intensity of magnetization.
If 1 by T is being increased, temperature will decrease or temperature will increase?
1 by T is increasing means, sir, it will increase, right, sir?
So intensity will also increase, na?
Intensity will increase, magnetization will decrease, right, sir?
So will it be a straight line graph?
No, sir.
It will not be possible, kada? Because
yes.
It is inversely proportional.
Yes.
Isn't it?
Yes, sir.
So it is not possible. Second one you see right now. Second one is also same, na?
Yes.
See here right now what is happening. If 1 by T is being increased, that means H by T increases. then temperature will be decreasing and intensity will be increasing. Kada?
Yes,
So
sir.
now
This
what
is
is
also
happening
not
right now?
possible.
Yeah, this is also not possible.
Fourth option is possible, sir, actually.
Why?
Sir, because as this is increasing, sir, temperature H by T is increasing, I is decreasing, no, sir.
Hmm.
So that's why that is possible, right, sir? Fourth option.
This will become saturation. Kada? There is a saturation point I told you. After a certain interval of time, it is not possible to increase.
Fourth
Isn't it?
one?
So
Okay,
it will
yes.
increase and then it will become saturated.
Okay, sir.
Isn't it? So this will be a possible. And
Okay.
fourth one, so it is not possible because it is rectangular hyperbola. That equation it is also not possible.
Okay, sir.
Clear?
Yes, sir.
So this is not possible. Only third option. Chalo. Next one is
So
ferromagnetism.
due to the saturation point, that's why the
That will
third
become
option
for
is.
me constant.
Okay.
Okay, na?
Yes.
The next one is what beta for me? Ferromagnetism. Ferromagnetic substances are those which will get strongly magnetized in the direction of the field when they have been placed in an external magnetic field. So they are getting strongly magnetized. They are getting strongly magnetized in the direction of your field.
Yes, sir.
So they are getting strongly magnetized. They are getting strongly magnetized in the direction of your field. So intensity of magnetization, that is I, is very large, and this one is your positive and varies non-linearly with your H or temperature. However,
Yes,
in
sir.
each case, it has an upper limit called as of what? Saturation of magnetization, IS, which depends upon the nature of your material. That means if I'm drawing the graph between intensity and H, it will slowly increase and becomes for me constant after a certain interval of a time. This is called as of your saturation. If I'm drawing the graph between your intensity and temperature, from the saturation, it will decrease up to a critical temperature, it will be decreased. This will be the graph.
Okay, sir.
Okay.
Yes.
The next one, let's see. The susceptibility is here right now very large. That is 10 to the power of minus 3 to 10 to the power of 5. And it varies with the temperature in a complex way. That means T is greater than of a critical temperature. So
Okay.
susceptibility is right now here. C is equals to some constant C dash divided by T minus TC. TC is known as of your Curie temperature and C dash is nothing but of your constant. Okay.
Yes.
And T is the temperature of the material. Okay. So it is
Yes.
T minus T dash. Isn't it? So that means whenever a ferromagnetic metal is heated, it becomes paramagnetic at a certain temperature. This temperature is called as of your Curie
Good.
temperature. Okay. When a
Okay, sir.
ferromagnetic material is being heated, what happened? It becomes to a
Paramagnetic.
paramagnetic substance at a certain temperature. This temperature is called as of your Curie temperature.
Sir, it changes, means does the Curie temperature for each substance change, sir? For
Yeah,
each
change.
ferromagnetic substance?
Yeah, exactly. The first one, it is not depending on temperature. Second one is inversely proportional to temperature. And here
Yes.
susceptibility is inversely proportional to T minus of TC part of pressure.
Yes, sir.
The relative permeability here is very large beta and it varies non-linearly with your H. That means mu R value is very large means P value is much greater than of your external magnetic field. That is the reason more crowded magnetic lines of fields will be passing through the material. So it is strongly magnetized. Whereas
Yes,
in
sir.
the paramagnetism, magnetic fields are being passing, but there are only lesser number of magnetic fields are being passing. Whereas in this one, you see, if we take the diagram, more crowded number of magnetic lines of the forces are passing. That is the reason it is more magnetized. That is the reason we say that a ferromagnetic material is strongly attracted by the field. So in a non-uniform field, they have a strong tendency to move from a region of the weak to your strong fields. Okay.
Yes.
See here. The ferromagnetic material can have a net magnetization even in the absence of an external field beta, which is called as of your spontaneous magnetization, and are always in the crystalline solids like iron, cobalt, nickel, and their alloys. Permanent magnets are made from the ferromagnetic materials beta. This is something very much important. You need to remember ferromagnetic material particulation. So this is something right now very important. What is this? This point. So
yes,
permanent magnets, very dark.
Yes.
Yeah. Permanent magnets are made from the ferromagnetic material.
Okay.
Competitive examination.
Okay.
Ferromagnetic materials are due to what? With a spin of your orbit interaction due to interaction of the spin of electrons of one atom with that of your neighboring atom. A ferromagnetic metal can be divided into small region called as of your domains. and each domain is completely magnetized, but direction of the magnetization is different, and hence the net magnetization here, it is right over me how much? Zero. Net magnetization is equals to zero. When a magnetizing field is been applied, the material get magnetized either by domain growth through the wall displacement in a vehicle field, or by the domain rotation. It may be due to the rotation, or it may be due to the growth of the magnetic field in the given. Like see here, I have drawn the diagram. Unmagnetized material, there will be domains like this randomly.
Yes, sir.
Magnetization by the domain growth. That means if the region is been increasing, so maximum number of this one will be in one simple region, isn't it? And if
Yes,
you are
sir.
keeping a strong magnetic field, magnetization by the domain rotation, that means each region will be same, but there will be rotating continuously. Clear?
Yes. Yes.
So that was about your ferromagnetic materials part of relation. Is that clear?
Yes, sir.
Isn't it? So if I'm drawing even the graph for this one better right now, for this one, we are having the susceptibility graph of a certain region. I'll just take this one, take a page. Yeah. Okay. See this one. This one is your susceptibility versus your temperature. In temperature, we generally take in terms of what beta? Kelvin. You know that it is changing from ferromagnetic to diamagnetic beta. So first the graph will be something like this. Then it will become constant for certain time part of relation. Then this region is called right now for me your ferromagnetic material. Okay. Then
Yes.
from there it is continuously changing and it will become like this. And this region is your paramagnetic region. This is your paramagnetic region. So this is the region A and this one is your region B. And the temperature at which it is changing from ferro to paramagnetic is called as what beta for me? Sorry, paramagnetic to ferromagnetic is called as what beta? Curie temperature part of relation. Is
Yes.
it clear?
Yes, sir.
Isn't it? So for paramagnetism, critical temperature is how much for me? 0. Isn't it? So that is
Yes.
the reason we write susceptibility is inversely proportional to 1 by T minus of your Tc.
TC.
Isn't this is known as of your Curie law. Another
Okay.
scientist who has been given with this, isn't it? So when T is greater than of your Curie temperature, susceptibility will be equal to your C divided by your T minus of your Tc. For
Okay.
paramagnetic substance, what is happening? Can you tell me better? For paramagnetic material, for your paramagnetic material, Curie temperature is 0. That is the reason susceptibility will become for me C by T. If
Yes.
Curie temperature is becoming 0, susceptibility will be inversely proportional to this one. Okay.
Yes.
That means at a temperature above the Curie point, the temperature above the Curie point, a ferromagnetic material becomes an ordinary paramagnetic material whose magnetic susceptibility will obey what beta? Curie law. Is it clear? At a temperature of above what beta? Critical point or Curie point. This point is known as of your Curie point. Is known as of your Curie point. So temperature above the Curie point, a ferromagnetic material becomes an ordinary paramagnetic material whose magnetic susceptibility will be obeying what law beta? Curie's law. So according to this law, temperature above the Curie temperature, the magnetic susceptibility of ferromagnetic material is inversely proportional to your what? T minus of your T naught partition. Okay. So these are the some of the basic things you need to remember better. That's it. So what is a Curie temperature ante? Curie temperature ante at a certain temperature, ferromagnetic material pass over the paramagnetic material. This transition of the temperature is called as of your Curie point or Curie temperature.
Yes.
Generally, the Curie temperature for iron is, generally if we take for iron, Curie temperature is approximately 770 degrees. Okay, you can convert that into Kelvin better if it is required for.
Laboratory we can do this, right?
Yeah, we can do it all bit, isn't it? So the ferromagnetic material will be of the behavior of a substance becomes what better? Temperature dependent or temperature independent?
Temperature
The
dependent.
temperature dependent. That means when
Yes,
temperature increases, magnetization decreases and susceptibility will decrease. I can write even here right now here. When temperature is increasing, I value is decreasing. So when I value is decreasing, susceptibility also decreases.
Yes.
Is that clear?
Yes.
Is it clear?
Yes.
isn't it? So what is the susceptibility beta? It is very large, and susceptibility is positive or negative? Susceptibility is positive.
Positive.
The value of this one is approximately 10 to the power of 3 to 10 to the power of your 5.
Okay.
Clear?
Yes, sir.
That was about your temperatures, and these are some problems I'm sending you right now. You
Okay,
please
sir.
try to complete this one and let me know in the tomorrow session the answers for this one.
Okay, sir.
Okay, na?
Yes, sir. Thank you, sir. Bye, sir.
Okay, bye.